So we're going to talk about light waves in the electromagnetic spectrum and then how to use the light speed equation. So just to review, the electromagnetic spectrum are the different types of light, including visible light, the rainbow. Here are some of the wavelengths of the different types of light. And just notice that to the right is the low frequency and to the left is high frequency on this chart. So a little bit of information about visible light. You can pause if you'd like to read that. The important thing here is that the color of light depends on its frequency. If you have a different frequency of light, you're going to have a different color of light or a different type of light wave, like a radio wave or a microwave. That is very important. Depends on its frequency. So converting between nanometers and meters, you see that these wavelengths are in nanometers. A nanometer is 10 to the negative 9th. It's a billionth of a meter. And the easy thing about this, you don't have to make it harder than it is. If you have 540 nanometers and you are working with that in your calculator, it's not in proper scientific notation, but that's okay. All you're going to do is replace nanometers with negative e to the negative 9 times 10 to the negative 9. So if you have 540 nanometers, you would just put 540 e negative 9 in your calculator. You have to remember to do the e negative 9 to convert it to meters, but it doesn't have to be in proper scientific notation. However, proper scientific notation would be 5.4 times 10 to the negative 7th meters. So here's just some practice for this particular concept. So if I was given 740 nanometers as a wavelength of light, then I can just put that into my calculator with 740 e negative 9 and then just go on my merry way. However, the proper scientific notation would be 7.4 times 10 to the negative 7th meters. So see if you can practice on the next 3 lines, push pause, and then I'll show the answers. Okay. So here's your answers. You can see that there are some similarities. This one is wrong. Let me fix that. That's 560. No, it's not wrong because I was given this, and I'm not going to bother to put that into the other one if I'm using my calculator. So I would just type that into my calculator. It would also be 560 e negative 9 if it was given to you this way. Okay. So the light speed equation is the same equation we've been using. Velocity is equal to frequency times wavelength. The difference here is that we know the velocity of light. Light speed is 3 times 10 to the 8th meters per second, or 300 million meters per second. We generally use c to indicate light speed, like E is equal to mc squared, Einstein's equation. So when you're doing light, a lot of times you'll see c is equal to frequency times wavelength as the light speed equation. And for those of you who pay more attention, frequency is often used with the Greek letter nu, which looks like a V. So C is equal to nu times wavelength. It looks like V times wavelength. I don't write it that way, but if you see that somewhere, this is just nu is the same thing as F. Okay, so what is the frequency and color of light with a wavelength of 710 nanometers? Well, we can easily see the color of the light on this particular chart because they've given us the wavelength. So 710 nanometers is right here, so it's going to be red light. But the frequency, we're going to have to use that equation. So C is equal to frequency times wavelength, and I'm looking for frequency. So frequency would be C divided by wavelength. C is the speed of light, so 3 times 10 to the 8th divided by the wavelength, which was, I can't use 710 nanometers, I have to put it into meters. So 710 e negative 9. And I get that frequency, when I put it in my calculator, is 4.23 e to the 14th hertz. I would suggest you pause and make sure you can get that answer in your calculator. Okay, so let's practice with the next one. What is the color of visible light with a frequency of 6.2 times 10 to the 14th hertz? Well, with this given me frequency, I can't find frequency on this chart. I need wavelength, so I need to solve for wavelength. C is equal to frequency times wavelength, so wavelength is going to be C divided by F. And C is the speed of light, so 3 times 10 to the 8th divided by frequency, which is 6.2 times 10 to the 14th. I'm going to put E in my calculator. When I put that in, I get 4.84 times 10 to the negative 7th, and that's in meters. And this is what my calculator gives me, which is proper scientific notation, but to convert that into nanometers, a nanometer is times 10 to the negative 9th. So that's going to be 484 nanometers, which we practiced earlier. 484 is right about here. So blue-green-ish. Again, pause and make sure you can get this and you know how I got this. So what type of electromagnetic wave has a frequency of 30 gigahertz? And a gigahertz is 10 to the ninth. Okay, well, I'm given frequency, but this is in wavelength, so I need to use the equation to get the wavelength. Wavelength is equal to C over frequency. I just rearranged that already in my head. C is going to be 3e8, speed of light, and the frequency. Okay, so 30 gigahertz. I need to write this in hertz, but it's easy because gigahertz is 10 to the negative ninth. So 30 times 10 to the negative 9, or excuse me, 30 times 10 to the ninth, or 30e9. Then I can put that into my calculator, and I'm going to get 0.01, and it's a wavelength, so meters. Okay, I don't see that over here, but if I take 0.01 meters, and we've been converting between centimeters and meters, and so to get to centimeters, I can move 2 to the right, and that's going to be 1 centimeter. And 1 centimeter is going to be somewhere between 1 millimeter and 10 centimeters, so we're talking radio waves. Pause, make sure you can get all of these answers. Okay, and then the last one, oops, I just showed the answer, but what type of electromagnetic wave has a wavelength of 4.7 times 10 to the negative 13th meters? Well, this is in frequency, so I need to change to frequency. Frequency is going to be speed of light divided by the wavelength. Speed of light, as always, is 3e to the 8, and the wavelength is 4.7 e to the negative 13. I can just put that in like that. And then this is going to give me a frequency of 6.38 times 10 to the 20th hertz. And that is times 10 to the 20th is going to fit right in here. So that's going to put me in the gamma ray. Okay, so if you will go into positive physics, you will be able to see that there is wave equations, 5.13. This is where you're going to practice. I think there's 5 problems. You're going to practice what we just did. And then 5.14 has some more vocabulary words to go back through. And you have a test coming up.